Okay, recall that we mentioned that polynomial functions have constant finite differences, and we can express a polynomial function in the form of f of x is equal to axn plus bxn minus 1 plus cxn minus 2 plus, and I'll just keep going to some coefficient, or sorry, to some constant e, all right? So this is the general template of a polynomial function, and we stated that they had constant finite differences, and whatever those finite differences, whichever finite differences were constant, would tell us the degree of the function. Furthermore, we also said that the degree of the function would tell us the behavior of the function, right? And we made this chart where the degree and the behavior were related. If the degree is 1, we have a linear function. If the degree is 2, we have a quadratic function. If the degree is 3, we have a cubic function. If the degree is 4, we have a quartic function, and if the degree is 5 is quintic, and you can keep going with this, but for the most part we'll just mainly be looking at the first 5 degrees, if anything. Okay. We can understand that knowing the degree of the function can help us to understand some of its behavior, specifically its sketch of its graph, right? But we want to create a general statement regarding the properties of all polynomial functions, right? So that way we're not just restricted to a degree of 5, right? Remember that degree is the highest power on a polynomial function. So before we start with our description of each of these polynomial functions, let's look at some general rules here, right? So let's take a look at two types of degree functions. So degree is the highest power on a polynomial function. And the two types of polynomial functions in terms of the degree can be even degree polynomial functions. So even degree polynomial functions have, well, basically even degrees, right? So their degree is an even number, right? And we'll also look at odd degree polynomial functions, right? And basically the degree is an odd number. Okay, so like for instance, if we had a function that looks like this, let's call this f of x is equal to x cubed minus 5x plus 4, we can understand that the degree here is 3. It's the highest power on the function, and this essentially would be an odd degree polynomial function. Okay, and if we had something like this, g of x is equal to x squared plus 3x to the power 4 minus 5x cubed, well, our degree here is 4 because that's the highest power on the independent variable, and this would be an even degree polynomial function. Okay, now you're probably wondering, okay, why do we need to classify even and odd degrees? Well, it actually tells us a little bit about the behavior, specifically the end behavior. Now, what is the end behavior of a function? Okay, well, an end behavior of a function right? The end behavior of a function is basically the value of y when x approaches positive or negative infinity. Okay, so I think the best way is to draw this out, right? This is our function, okay, and this is a linear function, right? And if this is our function, this is the x-axis, this is the y-axis, right? If we go towards this arrow here, this is positive infinity for x. If we go to this arrow here, it's negative infinity for x, right? If I go, as x approaches positive infinity, look what happens to y. You're going to keep extending this line outwards, and y will also approach positive infinity. So as x approaches positive infinity, y will also approach positive infinity, okay? So how we can look at this is the end behavior of y when x approaches infinity, right? So the end behavior for y when x approaches infinity is positive infinity, right? So what we can do is we can look at the direction of the arrowheads, right? And the arrowheads just means that the function is continuous, so it's not restricted within a certain interval. Now let's take a look at the other scenario as we go down this way. As x approaches negative infinity, right, you can see that y is going to go down, right? This is positive infinity for y, this is negative infinity for y. And as x approaches negative infinity, y will approach negative infinity as well. Okay? Now, you can understand that when x approaches positive infinity, y approaches positive infinity. When x approaches negative infinity, y approaches negative infinity. These are what we call the end behaviors. Okay, you can see that, and this is what we call opposite end behaviors. If the two end behaviors are opposite, they don't point in the same direction, we call these opposite end behaviors. Okay, let's take a look at another example where we have similar end behaviors. All right, let's consider this function. This is actually a quadratic function, and you can imagine that because it's shaped as a parabola, and you can imagine here that this is x and this is y. This is positive infinity towards x, negative infinity of x, positive infinity of y, and negative infinity of y. As I go towards positive infinity, as x approaches positive infinity, look what happens to y. Y is basically increasing this way if you follow the trace, and y is approaching positive infinity as well. Okay. Now if x approaches the opposite direction, negative infinity, you can see that y is also going up this way, and you can see that y also approaches positive infinity. Okay. So in this case, because the two end behaviors are in the same direction, right, therefore they have same or similar end behaviors. Okay, so the previous example, we looked at opposite end behaviors here, right? These guys, this was an opposite end behavior, right? But here we have similar end behaviors, okay? And another thing you can note here is that this was a linear function, right? So this was an x to the power 1. The degree was 1, so this is actually an odd degree function, right? Versus this was a quadratic, so this was an x to the power 2 function, right? And as a result, this is an even degree function. Well, this is actually a more universal rule, right? And what I want you to really understand here is that all even degree functions have similar end behaviors. They have the same end behaviors. Okay, so all even degree functions have similar end behaviors, whereas all odd degree functions have opposite end behaviors. Okay, so even degree functions have similar end behaviors, odd degree functions have opposite end behaviors. Now this is really important, right? So this will give us a general rule for basically any kind of degree polynomial function that you encounter. Now these rules are also dependent on the leading coefficient. Specifically, if the leading coefficient is negative, right? So A, we said, is the leading coefficient. Excuse me. And now let's take a look at when A is equal to, what we need to do is we need to look at the sign of the leading coefficient. A can be positive or A can be negative. Okay? Now if you tie this in with n, right, the degree, there's going to be specific characteristics that you want to look at. Now if n is equal to an even number, and n is basically the degree of the function, right, then this is an even degree polynomial function. Okay. However, if A is positive, right, if A is positive, then what you're going to see here is that the end behaviors are going to be the same because all even degree functions have the same end behavior. I'm going to use EB for end behavior actually. The end behaviors will be the same, but they'll always point to positive infinity. So because they're always pointing to positive infinity, if you have a positive even degree polynomial function, okay, here is our quartic function. A positive even degree polynomial function will have the same end behaviors. Both of them will be positive infinity, and you'd actually find the end behaviors in quadrants 1 and quadrants 2. So this is called a positive even degree function. Okay. Now if a is less than 0 and n is basically an even number, right, the end behavior will still be the same, but it'll both be negative infinity, right? So basically you'll have a negative even degree function, and what it would look like, here's an example of a negative even degree function. Right, the end behaviors would be in quadrants 3 and quadrants 4. Okay, so make sure you can note this, and you have to memorize this out because this is true for all positive and negative even degree functions. Okay, let's take a look at odd degree functions. Okay, let's say if n is an odd degree. If a is greater than 0, then what we're going to get here is a positive odd degree function. So here's an example of a positive odd degree function, right? So you can notice here that odd degree functions, the end behavior you'd have opposite, and specifically the two end behaviors will be found in quadrants 3 to quadrants 1. So we'll start in quadrant 3 and end up in quadrant 1. Okay, and this is true for all positive odd degree functions. So this is a positive odd degree function. Okay, and if you have a negative degree, like if a is less than 0, right, and you still have an odd degree, right, then basically what your function will look like right, this is quadrants, well, this was 1 and 3, right? This is quadrants 2 and 4. So in a negative odd degree function, the end behaviors are still going to be opposite, right? You can see that the end behaviors here, this is positive infinity, this is negative infinity, right? So the end behaviors are still opposite, but this time they're basically going from quadrants 2 to quadrants 4, right? So this is a negative odd degree function. Okay, so it's a negative odd degree function, and it's going from quadrants 2 to 4, right? So this is true for all positive and negative odd degree functions, right? So to recap, to summarize, right, the degree can tell us a few things about the characteristics of functions, right? And if the degree is an even degree function, right, you're going to have the same end behaviors, right? But if it's a positive even degree function, then you're going to have the end behaviors in quadrants 1 and quadrants 2. If it's a negative even degree function, you will have the end behaviors in quadrants 3 and quadrants 4. Okay. Now, if n is an odd degree function, odd degree polynomial function will have opposite end behaviors. If it's a positive odd degree function, we'll find the end behaviors in quadrants 3 and quadrants 1. And if it's a negative odd degree function, we'll find the end behaviors in quadrants 2 and quadrants 4. Okay, so keep this in mind, and I'll show you guys some questions later on to kind of illustrate some of these.